today's video we have brought you a very nice geometry problem. Here's the figure show. We have ABC as a triangle, and also we have a circle is crossing the segment BC at the point M at midpoint. M is a midpoint of the segment BC. So the circle with the radius R, okay. Also we have another following information on this triangle. We have the angles theta, double theta. We have phi equals pi over 4, and we have the following distances. From the point Bn equals number 1, from the point N to M equals y, from M to A prime equals z. Now our goal, we are going to evaluate the area of the big triangle ABC, okay. So if you would like to give the hands of subscribe previous solution, go ahead with this video when you come back to see the solution, okay. By the way, don't forget to hit the subscribe button and support the channel, like, comments and subscribe. Now let's jump into solution. We have a nice information here, since we have phi equals pi over 4, which means the other angle is equals pi over 4 as well, because we have this angle as a right angle, pi over 2, which make the total of these angles pi, okay, in the triangle. So it's absolutely is pi over 4 here, which means we have isosceles triangle. In the other words, this distance EA prime equals E prime C, which means each is going to be the same distance for both segments. We get each here, also each here, okay. So the next information, so we have the right triangle. We are going to take advantage of two right triangles. We get this triangle EA prime B, and also we have EA prime N. We are going to apply trigonometric formula on both triangles when where we have double theta and where we have theta, okay. Now let's do that, and also we have a nice formula we can apply here. So we know tangent of double theta is going to be double tangent theta all over 1 minus tangent square theta. You know, it's more known formula, this one. We know tangent of x plus y equals tangent x plus tangent y over 1 minus tangent x is multiplied by tangent y. So this is the formula that I'm going to apply now. So then notice here the same tangent double theta equals opposite, which is this one, over adjacent, each, which is each, over this distance, this distance E prime N. We know E prime N equals Z plus Y, okay, which is each all over Z plus Y. So we are going to determine the value of Y. It's more simple since we have a midpoint here, this circle crossing this segment at the point M. So we have the half of the distance BM equals MC, which means this one is R. Also this one is a R, which means this Y equals R minus number 1, okay. So I get here, I'm going to replace it, H over Z plus R minus number 1. It's more simple, okay. Now let's work on the other side. Let's calculate tangent of theta. Tangent of theta, which is this one, we have E prime B as a right triangle, which means I will have also each all over this distance. This distance is going to be obviously R, which is the radius of this circle, okay, plus this small distance, which is Z. So I get R plus Z, okay. Now since we get tangent theta and the above formula here, I'm going to take it and insert it back into there, okay. So I get here, I'm going to put this one first. I get each all over Z plus R minus number 1, which equals 2 times is multiplied by this one, each all over R plus Z all over 1 minus each all over R plus Z quantity square. If I'm going to simplify this one, I'm going to cancel R plus Z. It's going to give us 2 is multiplied by each all over R plus Z is multiplied by R plus Z quantity square, because I'm taking the inverse of this one, all over Z plus R quantity square minus H square. It's more simple. Obviously I'm going to make some simplification here. This R plus Z square is going to cancel down to R plus Z, because I will be left with this one here, and also this H is going to be cancelled out from the left and the right. I will be left with the formula. I get 1 over z plus r minus number 1, which equals 2 times r plus z all over r plus z quantity square minus h square. Also, if you take a look here, we have h square, we have h as a distance equals this distance to the radius of the circle minus this small distance, which is z. Okay, so I'm going to replace that. So I get 2 r plus z all over r plus z quantity square. So r minus z quantity square. Now it's more simple to simplify the denominator because we have a difference of two squares here. Let's do that. So I get 2 factor r plus z all over r plus z minus r plus z factor r plus z plus r minus z. Okay, so I will have a lot of cancellation here. This r will be cancelled out with this one, and this z will be cancelled out with this one. I will be left with 2 times z. This one will have 2 times r. One of the two is going to be cancelled out from numerator and denominator. So I will be left with the following: r plus z all over 2 times rz. Okay, so let's bring this formula over here. So by crossing the multiplications, I get 2 times rz, which equals this one is multiplied by this one. So I get here r plus z quantity square minus r plus z. It's more simple. I want to simplify this one more. I get 2 times rz, which equals r square plus 2 times rz plus z square minus r minus z minus r plus z, like this. So 2rz is going to be cancelled out with this one. I will be left with following: I get r square plus z square by taking this one to the right because I get 0 here. So I will have r square, I have r square plus z square equals minus r minus z, which equals 0. Okay, so we'll be ended with the following: r square minus r, which equals z minus z square. Okay, so I have ended with this nice formula. I'm going to take this equation at the top and continue solving our problem. Now we are going to build a nice relationship between r and z. Okay, so if you take a look at the right hand side of this triangle, we get a right triangle here. So we are simply going to apply the trigonometry formula on this one. So it's more simple. Get cosine of pi over 4, which is this one, equals adjacent, which is h. It was r minus z, all over hypotenuse r. Okay, I'm going to simplify this one more. It gets r over r, which is 1 minus z all over r. Cosine pi over 4 is square root of 2 over 2. Okay, bring the constant term to the left and the variables to the right. So I get the following: get 1 minus square root 2 over 2, which equals z over r. Let's multiply both sides by r. So I get z, which equals 1 minus square root of 2 over 2 is multiplied by r. Now we have found z in terms of r. Let's take this one and insert it back into the original equation, this one. Okay, so replacing z here, so I get r square minus r, which equals 1 minus square root of 2 over 2, r minus 1 minus square root 2 over 2, r square. Okay, so after replacing this one into this one, we get to this one here. So now, since we get r everywhere, I'm going to cancel one of the r, because you know r is a distance, is always strictly superior than 0. Okay, so I will have r minus number 1, which equals 1 minus square root 2 over 2 minus 1 minus square root 2 over 2 square r. Okay, since we got r, I'm going to move r as a variables to one side and bring the constant to the other side. So I will have the following: I get number 1, I'm going to take r as a common factor here. So what to do, I'm going to simplify this one. Let's multiply both sides by number 2. Thus I got r equals 4 minus square root of 2 over 5 minus 2 square root of 2. Previously working on this equation, we found the value of r equals to this one. Now we are simply to find h, because we know h, we know that we have a right triangle here. I'm going to apply the Pythagorean theorem on this triangle. As a right triangle, h square plus h square, which is 2 times h square, equals the hypotenuse, which is r square. So in the other word, I'm going to take the square root on both sides. I get h equals r all over square root of 2. So simply going to take this formula of r, I'm going to take this formula involving r multiplied just by 1 over square root of 2 to find h. h equals 1 over square root of 2 is multiplied by 4 minus square root of 2 all over 5 minus 2 square root of 2. Okay? So I will have the following. It gets here 4 minus square root of 2 all over, this one becomes 5 square root of 2 minus 4. Okay, so what to do now? We know the area of the S equals the altitude. H is multiplied by the base. The base is this distance BC, which is the radius of the circle is multiplied by 2, which is 2r all over number 2. 2 will be cancelled out with 2. I get h is multiplied by r. It's more simple. We get h equals 4 minus square root of 2 all over 5 square root of 2 minus number 4. All it was is going to be multiplied by this one, by 4 minus square root of 2 all over 5 minus 2 square root of 2. So I will have here 4 minus square root of 2 quinary square all over these things. When you calculate this one, it will be ended with 18 minus 8 square root of 2 all over 33 square root of 2 minus 40. Okay, so I didn't use a calculator to calculate the exact value of this one. Thank you for watching. I will see you next video. Bye.